In today's video, I'm going to explain about the ionization potential of the d block elements. What is this ionization potential? It is the amount of energy required to remove the loosely held electron from the outermost shell. Note that the ionization potential of the d block elements lie in between the s block and the p block, which means that the d block elements are less ionic than the s block elements but more covalent than the p block elements. Here we have the first, second and third ionization potentials for the 3D series elements. Just have a look from here. Now we see that as we move from left to right, okay, across the period of in the periodic table, the ionization potential increases, even though the increase is not regular. Now that the increase is not regular because the atomic radii vary slightly. Now you can check that one from the playlist that I have provided in the description box below. Just click on that one. You will find out the video about the atomic radii, and from that only you will understand about ionization potential better if you know the trend in the atomic radii. Okay, so now have a look here. But why does zinc have high ionization potential? That one has to do with the electronic configuration. What is the atomic number for zinc? It is 30. Now the valence shell electronic configuration for zinc would be 3d10 4s2. Now we see that the 3d orbital is completely filled, so it is not easy to remove all these electrons from here. That's why the ionization potential for zinc is very high, that is 906.4. okay, and then we have another interesting question here. The question is, the second ionization energies for chromium and copper are sufficiently higher than those of the neighboring elements on the left as well as on the right. Why? Okay, so just have a look from here. For chromium, the second ionization energy and that of copper are higher as compared to the neighboring elements on the left as well as on the right. We have to give the reason. Here you have to know the electronic configuration. For chromium, what is the atomic number? It is 24. So the valence shell electronic configuration would be 3d4, okay, 4s2. Okay, and then for copper it is 29, so it would be 3d9, 4s2. Now first you have to go for the first ionization energy. Okay, now the first ionization energy is the first energy that you are applying in order to remove one electron from this s orbital. So when you apply this energy, now you are removing one electron. So now the orbital would look in this way, 4s1. Suppose you are removing one electron by applying the first ionization energy or the ionization potential. In the same way, the first ionization energy for copper, you are applying this to remove one electron, then it would look in this way, 4s1. Okay, that is your first ionization energy. Now just have a look from here. In this orbital, 1 2 3 4 5, this is the 3d, this is the 4s. Okay, this electron here we have 4, 1 2 3 4 5 6 7 8 9. okay, this one electron from the s orbital can occupy this empty orbital here to make it 3d5, and finally we have 4s0. In the same way, this one electron from 4s can occupy this one to give 3d10, and here 4s0. okay, then just have a look. This one is a half-filled orbital, d orbital. This one is a full-filled d orbital, and we know that half-filled and full-filled orbitals are stable. So that's why in order to remove electrons from these half-filled and full-filled d orbitals, it becomes very difficult. That's why the second ionization energy for chromium and copper are sufficiently higher than those of the neighboring elements on the left as well as on the right. Okay, I hope you have understood about this one. That's all. Thank you.